Alkenes are hydrocarbons with at least one double bond between the carbons. These are unsaturated. So you find the longest carbon chain and use the root name. Number the carbons starting from the end closest to the double bond. This part's really important. So you've got to have the end closest to the double bond as your starting point. Identify the number that the double bond starts on and add this to the suffix ene. So if it's got 4 carbons, its root is bute. Then comes the number of the carbon where the double bond starts, and you follow it up with ene, bute number ene. And then you identify and name any side groups just like you did for alkanes. Okay, let's take a look at this structure. Here's our longest carbon chain, so there's three carbons. So the root is going to be prop. And if we start numbering the end closest to the double bond, that's carbon 1, that's carbon 2, and that's carbon 3. So the double bond starts on carbon 1. It's between carbon 1 and carbon 2. So the root is prop 1 ene. And there's no side groups on this, so this is the name, prop 1 ene. So that's the IUPAC name for this compound. Sometimes it's just called propene. Because the double bond is always going to be after carbon number 1. So if the double bond is on the other end, you would start counting from that end. It's still between carbons 1 and 2. So it becomes redundant, but don't drop it. Always put it in because you're just learning. So prop 1 ene. Okay, this structure, I'm not showing the hydrogens, I'm just showing the bonds just to keep it a little neater. So here, find the longest continuous carbon chain. Here we go, straight chain. There's 4 carbons, so the root is bute. The double bond is closest to this end. So 1, 2, 3, 4. So the name for this compound would be bute for 4 carbons, 1 ene. Okay, I'm just going to move this up. All right. Okay, so this structure, again, I've just dropped the hydrogens for instructional reasons. Here's the longest carbon chain. So it's still 4, so it's definitely bute, but this time the double bond occurs after carbon 2. And it doesn't matter which end you count from, it's still after carbon number 2. So this is bute 2 ene for the double bond. Now, this, however, is one of the cis-trans isomers. The carbon 2 and the carbon 3 involved in the double bond have 2 different groups on them. They have a hydrogen and a CH3 group. So this can have a cis-trans isomer. 1-butene or but-1-ene does not have cis-trans isomers because this carbon has 2 of the same groups on it. It's got 2 hydrogens. You have to have 2 different groups on a carbon to have cis-trans isomers. So because the hydrogens across the double bond are going up, they're on the same side, so this would be cis but-2-ene, and if they went like that, where here's our double bond, and one hydrogen's going down and the other one's going up. They're opposite from each other, so that would be trans bute 2-ene. Okay, this compound has a double bond in it, so it's an alkene, and the longest continuous carbon chain is there, so it's got 5 carbons. So counting from the end closest to the double bond, that's 1, 2, 3, 4, and 5. So the root is pent for 5. The double bond is after carbon number 1, and double bonds with an ene, so it's pent 1-ene. That only accounts for the first 5 in the straight chain, though. We also have this side group, which is a methyl, and it is on carbon 3. So this compound is 3-methyl pent 1-ene. Okay, this has a longest continuous carbon chain of 4, so this is a bute. The double bond comes after carbon number 1. Double bond, and then the methyl group is on carbon number 3. Alright, if you try and name this one, initially it looks like it's a 4-carbon chain again with a double bond and a methyl group. However, if you take your highlighter, longest continuous carbon chain, your carbon chain is actually 5 carbons long, not 4. So be careful when structures are drawn with a side group on what looks like an end carbon. It's not a side group, it is just part of the longest continuous chain. So this would be pent 1-ene. So you will never have a methyl group on a carbon number 1 or on the last carbon in the longest carbon chain. Here's a challenge. Try and name this. Pause the video, try and name this, and then check your answer. This is actually 3-methyl pent 2-ene. If you start from this end, don't lift your pen up, the longest continuous carbon chain is actually 5 carbons long, and that makes this carbon a side group. So you've got 1 carbon side group, so that's a methyl. And then your double bond starts after carbon number 2. So it's pent 2-ene. For drawing, basically you have the same rules as an alkane, but you must get the position of the double bond correct. It comes after the number in the suffix. And make sure that you have only 4 bonds per carbon. Sometimes people tend to put in 1 extra. Okay, let's draw 4-methyl pent 1-ene. So the suffix tells us it's a double bond, and the root is pent, so there's 5 carbons. The double bond comes after carbon number 1, and if that's carbon 1, then this is carbon 2, that's carbon 3, and that's carbon 4. You keep going in the same sequence. So 1, 2, 3, 4, and carbon 4 is where we put our methyl group. And the rest of the bonds and the hydrogens are placed. So if you were giving me this as an answer, you should put in all of your hydrogens. Now you could draw this as a line structure as well. You've got 5 carbons, so 1, 2, 3, 4, 5. The double bond comes after carbon 1, so between carbons 1 and 2. So that's how you show it's a double bond. And then you have a methyl group coming off of carbon number 4. So there's your methyl group. Physical properties of alkenes. So again, just like alkanes, they're nonpolar. They only have London dispersion forces, so they've got very weak intermolecular forces, low energy required to overcome them. Therefore, their boiling points and melting points are pretty low. Carbons 2 to 4 are gases at room temperature. They are not soluble in water again because they can't hydrogen bond with water, but they can dissolve in other nonpolar solvents. Alkynes, these are hydrocarbons with at least 1 triple bond, so that again they're also unsaturated. Now you name them the same as you do the alkenes, but the suffix is instead the number and then YNE. So don't forget, when we do hydrocarbons, the functional group, the name of the group of compounds, actually is used in the suffix of their name. So if you look at this compound, longest carbon chain here is 4, and the triple bond is right here in the middle. So start counting at the end closest to the triple bond. And for this one, it doesn't matter which end you count from, it's still the same number. It starts after carbon number 2. So this is called bute for 4 carbons, 2 because it's the triple bond comes after the second carbon, and then YNE. So this is bute-2-ine. Okay, I'm going to name this structure. Again, I haven't put hydrogens on the end of all the bonds just to make it a little clearer for instructional purposes. Alright, here, the longest carbon chain, 1, 2, 3, 4. So I could go down, but that would be 5, 6. Or I could keep going straight. 1, 2, 3, 4, 5, 6, 7. So my longest carbon chain is 7. So that means this is hept. And then I start counting from the end closest to the triple bond. So the triple bond happens to start after carbon 2. So this is hept-2-ine. Now we've got to account for the other carbons, the 2 other side groups. We have a methyl group here, and we have an ethyl, because there's 2 carbons in the chain, so we've got an ethyl group there. So what we have to do is alphabetize them. Methyl, ethyl. E comes before M, so the ethyl comes before the methyl. And then you put in the numbers to indicate which carbon they're on. So the methyl group is on carbon 5. So the methyl group is carbon 5. And the ethyl group is on carbon 4. So this structure is 4 ethyl, 5 methyl, hept-2-ine. There are no cis-trans isomers for an alkyne because the carbons with the multiple bonds between them have to have 2 different groups on them, and they only have 1. Right? Carbon number 2 here only has a methyl group, and carbon number 3 has everything else. So they have to have two groups. So you only get cis-trans isomers for alkenes. Drawing rules apply the same as alkenes. Okay, prop 1-ine. So prop means 3 carbons. Y&E means triple bond. The 1 means it comes after the 1. So that leaves 1 hydrogen here, none there, and 3 here. So this is prop 1-ine. It's often referred to as just propine because it doesn't matter which carbon it is. It could be here, but if you draw this structure, you would just start counting from the other end, so it's still 1. These are not isomers of each other. Pent 2-ine. Pent 2-ine, so we know the carbon chain is 5. After carbon 2, we have our triple bond. So then the rest of the carbons put in enough lines to make 4 bonds on each carbon, and then place all of your hydrogens. Okay, yes, you can do line structures for these. So propine, 1, 2, 3, and then the triple bond goes there between carbons 1 and 2. Pent 2-ine, 1, 2, 3, 4, 5, and the triple bond goes between carbons 2 and 3. So there's your triple bond. Physical properties, they're same really as the alkenes, but some have slightly higher boiling points than their alkenes of the same carbon length. And that's only because they're more linear, so they can get closer, and the London dispersion forces are more attractive to each other. So it's not a huge difference though.